This is page 87 of your math journal. We're going to call this one Functions and Graphs, or Equations and Graphs. Let's do that. Equations and Graphs. Alright, so we've been talking about writing function rules, and a function rule is just another rule name for an equation that represents a function. Okay, let's do that again. So a function rule is an equation describing the relationship between the input and the output. Okay, let's do one to start it off. Okay, if I have x and y, x being my input, y being my output, let's put in 0 here. 1, 3, and 4. So this one right here, 0 is going to be 2 as an output, 4, 8, and 10. Okay, so remember, we're trying to see what do I need to do to my input to get my output. So we first look and see if we're adding or subtracting. So this would be add 2. This is not add 2. That would be add 3, add 5. Okay, so adding 2 is not what's happening here. Let's see if it's multiplying. 0 times something would have to be 0. So it's not just multiplying, so it might be both. So let's take from here to here, see how much it changes. From 0 to 1, it changes 1. From 2 to 4, it changes 2. From 1 to 3, it changed 2. From 4 to 8, it changed 4. From 3 to 4, it changed 1, and from 8 to 10, it changed 2. So as this one grows 1, this one grows 2. So this is 2 times as much. This is also 2 times as much. Okay, so what we're seeing a pattern here, it's 2 times, the y is growing 2 times faster than the x. So 2 times 0 would be 0, but I have 2. What do I need to do to 0 to make 2? I would need to add 2. Okay, let's look here. 1 times 2 would be 2, but I need 4. 2 plus 2 is 4, so adding 2 again would work. 3 times 2 is 6. 6 plus 2 is 8. 4 times 2 is 8. 8 plus 2 is 10. So for each one of these, we have to adjust it and add 2 as well. Alright, with this, what I want you to see is for a linear function rule. This right here is going to be the rate. The rate is how many times faster it changes. Or the output changes. This right here is going to be the starting point. And this is where your input is 0. I'm going to change y here to output, because it's not always going to be y. Okay, this is going to be your general setup for an equation. So when you have something like this, if we were to graph it, it would look something like this. So try and write as neat as you can. Just going to make a first quadrant graph. We have to label it. So this one would be X. This would be Y. Now try to make these even. Okay, now looking at this, we're just going to plot these points. So we have X and Y. So together we have 0 and 2. So I'm going to plot that right there. 0, 2. 1, 4 is another point, so we're going to go to 1 on the X, 4 on the Y. Three, 8, so I'm going to go 1, 2, 3 on the X, 1, 2, 3, 4, 5, 6, 7, 8 on the Y. Notice, as long as you make your graph neat, this should be pretty close to making a straight line. If it was done on real graph paper, it would be a straight line. Now I can't fit 410 on my graph, but this right here is making a line. This is a graph of this function. Now look on here, you can see your starting point. Our starting point is where x equals 0. So I'd like you to make a little arrow there. That's our starting point. So that's where our graph is starting. Now see how this is 2 times as big? See how it's 2 higher? Well, look, if I go over 1 more, wouldn't that also be 2 higher? And this is 2 higher from there. So you can see how much it's changing. This is what determines how steep your line is. The bigger this number, the steeper it will be. So I want you to write equation of a line. Let's kind of box this off. Okay, an equation of a line is going to be the rate times the input plus the starting point. To get your output. Another way to look at this would be, they call it M for the rate. X is usually our input, plus, and then they put B for the starting point. Equals Y, which would be our output. So when you see this, it's just a way to help you remember the different parts when you're writing an equation. Okay, so we're going to try another one. Let's say we have a graph and we want to write an equation for it. So let's say we have the graph, looks like this. Try and make it nice and neat. Okay, this one is going to have a real life context to it, so we're going to give this one labels. This is going to be rainfall. This one's going to be snowfall. Okay, if we're given this, this one is going to be labeled by 1s. This one we're actually going to label by 10s. So this will be 10, 20, 30, 40. So this is how much rainfall is the same as how much snowfall as far as water goes. Okay, this corner is always 0. So 1 inch, 10 inches, 2, 20, 3, 30, 4, 40. Okay, let's put in inches here just so we remember what this was. Okay, now let's make a table from the graph. Our input is rainfall. Our output is snowfall. We're comparing rain and snow here. So if we have 1 inch of rain, it's the same as 10 inches of snow. 2 inches of rain, that's the same as 20 inches of snow. 3 inches of rain, same as 4 inches, or 30 inches of snow. 4 inches of rain, that's the same as 40 inches of snow. So if you can see a pattern going on here, you can even fill out more. But if we want to write an equation, we have our input, which is on the x-axis. We can call it x and y. We could also call it r and s if we wanted to. So what do we have to do to the input to get the output? Okay, I could add 9, but adding 9 doesn't work here, so it's not just adding something. 1 times 10 gives me 10. 2 times 10 gives me 20. 3 times 10 gives me 30, and 4 times 10 gives me 40. So I could do it this way as well. I could see that this went up 1, this went up 10, this went up 1, this went up 10. So I can do 10 times x to get y. So if I'm looking at that, I don't have to adjust anything, so there's nothing. So what would I be adding here? I could just leave it 10x, or I could write a plus 0, but that's your starting point. Look where your graph starts. When there is 0 inches of rainfall, there would be 0 inches of snowfall. So there's your starting point. So what does this mean to us? This means that each inch of rainfall is worth 10 inches of snow. Alright. And that's all I'm going to have you write down today. Is you just need to know, we already went over how to write an equation. I just want you to know the different parts of an equation and how to graph them.